is a neutron star class ship, which apparently these were designed during the Clone Wars to serve as second-line ships. I'm not sure if I can verify that. Okay, so that's the story in our galaxy. So this is what's happening in our galaxy, but I'd like to move away because there's so much more to space than just our Milky Way galaxy. And some of the things that we like to look at, and this is actually very close to the kind of work that I do myself, is what I call extragalactic sources. So these are objects, these are galaxies very far away outside our own galaxy, with very powerful mechanisms of particle acceleration. And what you see here, I think you don't have to pay too much attention on the scale here, but if you're interested, what this really is zooming in onto a part of sky very far away. It's, I would say, billions of light years away, and a few arc seconds, just a small portion of the sky, and what you see here is a jet of material that's coming out, and you can actually see this jet in this image. This is 4,000 light years across. This is 2,000 light years across. But you can zoom in. You can zoom in. If I were to zoom in over here to the inner tenth of light years of these objects, we can actually see very close now to the black hole that's powering these objects, not with gamma ray telescopes, but with radio telescopes. So radio telescopes have really done remarkable things in terms of trying to zoom into this region. And this one actually is a very high resolution image using an array of telescopes in Arizona, looking within sort of a tenth of a light year of this object. And it's like standing in New York and reading a newspaper in Los Angeles. That's the kind of resolution I'm talking about. It's just tremendous. What we are interested in with these sources is the particle acceleration that's happening in these jets. So these jets are, it's across huge distances in space. And one thing that you wonder, what we are interested in, is what kind of power can keep a jet collimated for that long? How can you? It's like standing in Nevis and watering the lawn, and your hose, the water spray, goes all the way to Manhattan. There's something in the jet. We know now that it's really a magnetic field that's kind of swirling around the jet to keep it all together. But with that kind of power in those jets, you have a lot of particle acceleration that's going on. So we like to zoom in on these sources because we want to first understand what kind of black holes are at the centers of these active galaxies and what kind of particle acceleration is happening in these sources. So just to come back to this, just to orient you, I'm not talking about, so our own galaxy, the world where we live in is not an active galaxy. The Milky Way is a barred spiral galaxy. It's about 100,000 to 120,000 light years across, so that's how long it takes light to cross it. It has about 200 to 400 billion stars. It's definitely powerful. It's not, this is actually a view of the active of the Milky Way galaxy, not what you would see from New York, unfortunately, but this is from Black Rock Desert in Nevada. You actually see this is a real image somebody took, which I forgot to credit, of our galaxy. The active galaxies that I'm talking about, it's much more powerful than our own galaxy. An active galaxy, you can think of it as sort of thousands of Milky Way galaxies, very powerful objects, extragalactic, very far away. Okay? And what we think powers these objects in the heart of these active galaxies is a supermassive black hole. This is a visualization. This is how we understand it and model it, is basically the gravity in these objects is tremendous. You have accretion, you have matter that's swirling around it, and you have gravitational potential energy being zoomed into these jets of material. You have particle acceleration. And we can now observe these sources across the electromagnetic spectrum, all the way from radio waves, X-rays, to high-energy gamma rays. And this is one of the main reasons for looking at these objects. So I thought, because black holes are so popular and everybody wants to, I'm sure you know more about black holes than I do. I thought I would include a couple of slides on black holes. It's a very interesting topic, and we know it's a construct of general